Hello students, how are you today? Hope you are all doing great. You're welcome once again to today's class. We've had several exciting classes here, and today will not be an exception. My name is Andy Onopite, and today I will be your mathematics teacher. Some of the previous classes we've had on this platform are sine and cosine rule, and the very last one was bearing and distance. And today we'll be treating the concluding part of this topic, bearing and distance. So let me use this opportunity once again to say a big welcome to you as we take a trip through bearing and distance. Let's go. In our last class, we were able to demonstrate and effectively define bearing, and also we talked about the different forms of bearing, where we said the 3 digits bearing, which is also called the true bearing, and of course the compass bearing. We also enumerated the features of the 3 digits bearing and that of the true bearing. We went ahead to convert bearings from one form to the other, from 3 digits to compass bearing, and from compass bearing back to 3 digits bearing. And lastly, we were able to work on forward bearing and backward bearing. And of course, backward bearing is also called the reverse bearing. So if we say A has a bearing of an angle from B, you can go ahead to find the bearing of B from A. They are called forward and reverse bearing. So today we'll be talking about how to effectively draw a triangle when we are given word problems in bearing and distance. But before doing that, we must be well grounded in the following topics. So a quick reminder of what we are going to use today. You must be grounded in Pythagoras rule. You must effectively know how to use your trigonometric ratios. Now, the Pythagoras rule and trig ratios are used for triangles that are right-angled triangles. So when you have right-angled triangles, you can use the trig ratio and of course the Pythagoras rule. Peradventure, you have other triangles that are not right angles. Then you go ahead to use your sine rule and your cosine rule. So these are some of the formulas and features we'll be using in today's topic. Let's go ahead to check few examples to demonstrate how this works. We have example 1, and example 1 says, from a point Z, 30 meters north of X, a boy walks 40 meters eastwards to another point Y. Find the distance between X and Y. And secondly, find the bearing of Y from X. Okay. Now, what do we do? How do we go about the question like this? The first thing for you to note here is the word from. Now, students always find it difficult to get these drawings done because of how to interpret the question, where to start from and where to proceed to. Where do you always start a bearing question from? You always start from the word from. From gives you the point where the entire triangle should start. Now, this question says from point Z, so I will start my diagram from the point Z. Now, that's my point Z. Where is point Z located? We are told it is located 30 meters north of X. Okay, so if Z is north of X, it simply says X is south of Z. So I will put my X somewhere below there, draw my cardinal point at my point X, and straight up the north, I'll draw it towards Z. Can you see that? Now it simply means that my point Z is on the north of X. That line I've drawn should be equivalent to 30 meters. Now that I am now at point Z, the question says the boy walks 40 meters eastward to another point Y. Now I draw my cardinal at point Z. I'll go towards the eastern direction, something like this. Good. To the point Y, and that should be 40 meters. Now, as we can see, my 40 meters is a little longer than the 30 meters. Although it might not be precise, but always try to make it real. In reality, 40 meters and 30 meters shouldn't take exactly the same measurement. So you will do well to make the 40 meters be a little longer than the 30, just to, bring real features to your drawing. All right. The last part of this diagram will be to connect your point X to the point Y, just as we've done right here. Okay, that part is done. Now our triangle is done. From a point Z, 30 meters north of Y, a boy walks 40 meters eastward to another point Y. Now our triangle is set. Now we're going further to say find the distance between X and Y. Find the distance between X and Y. Given this triangle, if you look at that point Z critically, you will notice that Y is on the eastern direction and X is on the southern direction. So that simply tells us that our point Z should be a right angle. So I'll put my right angle there. Good. Now we have it as a right angle triangle. And like we said earlier, once you have a right angle triangle, then you should know that you are using either the Pythagoras theorem or the trigonometric ratio. In this case, Pythagoras rule will work for us because we have two sides known and we have one side unknown in a right angle triangle. So I will quickly go ahead. Using my Pythagoras rule, I have it as 30 squared plus 40 squared equals to my z squared, which is the longest side and serves as my hypotenuse. 30 squared is 900 and 40 squared is 1600. Adding both together, I should have 2500. And if I solve that properly, having the square root of both sides, 2500 squared should give me 50. In other words, my side Z will have to be 50 meters. Okay, our first job is done. So I have found the distance between my X and my Y. And that's exactly what we can see on the screen. Let's see what the question B says. Let's find the bearing of Y from X. The bearing of Y from X. Now, once again, I will want to take note of the word from X. From X. It means at my point X, I will draw my cardinal point there and I will start to count in a clockwise direction for my angle. In this case, my cardinal is already there. So I will want to draw that. Can you see that? Please always take note of how we draw our cardinals and how we draw our angles. Always from the north, going in the clockwise direction to meet our line of reference. In this case, our line of reference is that which meets with the Y. With the point Y. Now, having this, if we are looking for that angle X, which will serve as our bearing from Y to X, we are simply going to use the sine rule. While we're using the sine rule, we have an angle known and we have the three sides known. That simply qualifies us to use the sine rule. And I'm using just my z and my x. If I should go further with this, putting my x as 40 and my z as 50, knowing fully well that my sine z will be sine 90. Sine 90, of course, is 1, so 40 over 50 should give us 0.8. Now, if my sine x is 0.8, then I should know that my x is the sine inverse of 0.8. If you punch your calculators properly, you should have x equals to 53 degrees. So x equals to 53 degrees. But because we want to represent it using a bearing form, the true bearing, we have to write it at 0.53 degrees as our x. Okay, so the bearing of y from the point x will now have to be 0.53 degrees. Okay, so we've been able to find the distance between x and y in this question, and also we've been able to find the bearing of y from x in example 1. Let's quickly go to example 2 and see a different form of word problem question. Let's see. This question says B is 60 kilometers away from A on a bearing of 130 degrees, and C is 80 kilometers away from A on a bearing of 242 degrees. The question says, find the distance of C from B and also the bearing of C from B. All right, let's start. How do we always start? We always find our word from. This question says B is so kilometers away from the point A. From the point A. Now, having identified our word, which is the from, we're going to start with point A. If I'm starting from point A, it simply means I am going to draw my cardinal at point A. So I will go ahead and draw an angle of 130 degrees in point A. And following our rules that says we must start from the north and draw towards the clockwise direction, along the clockwise direction. So if I do this, I'll be drawing my 130 degrees starting from the north, going clockwise to that angle. Now, a quick look at what I've just done. My 130 degrees did not stop in my first quadrant. Okay, we look at it very well. It has to be in the second quadrant. All right. How do we do this? We already know that my first quadrant can only house angle between 0 degrees and 90 degrees. Okay, then any angle between 90 degrees and 180 degrees should fall between the second quadrant, and that's where 130 degrees falls into. The third quadrant should cater for angles between 180 degrees and 270 degrees. Then the fourth quadrant is responsible for angles between 270 degrees and 360 degrees. So, little wonder I had to terminate my angle in 130 inside my second quadrant. And that's just the basic trick. The basic trick here. Know your angles and the quadrants that they fall into, then you are good to go. So let's continue with this diagram. 60 kilometers to a point B. The first part of the line is drawn. The second part says, and C is 80 kilometers away from A. Once again, from A. So, since we are drawing from A once again, I will take my cardinals in A and draw from my north going to the clockwise direction, through the clockwise direction, just like this. Yeah, I'm drawing 242 degrees. Now, before I draw, you should know that because 242 degrees terminates in my third quadrant, 242 degrees is between 270, 180 and 270, okay? That is where my 242 falls into. So it has to be inside my third quadrant. So I will draw, and whatever I draw now will end in my third quadrant. Please pay attention to the way the angles are being drawn. That is just the key in solving these questions. You get the diagrams correctly, then half of your work is being done. I draw my line going to my point C. Good. Now my line going to my point C is there, and the distance is 80 kilometers. Once again, my 80 kilometers is quite longer than my 60 kilometers. Not really accurate in measurement, but we just try to make it real and depict reality. We have to make 80 a little longer than 60. Okay? Then the last part of this diagram will be to connect my point C to point B. All right? We've done that. Now we have a triangle. So the first part now says, find the distance of C from B. The distance of C from B. Now looking at this triangle, I have two sides, but I do not have any angle. Okay, if you should zoom this in, I have side 60 and I have side 80. I do not have any angle. So what I'll do, I'll have to find the angle A. Yes, I'll have to find this angle A. How do I do that? I will have to subtract 130 from everything here, 360, to get my angle A. Okay, so let's do that quickly and see how it works. All right. My angle A, which is BAC, should now be 242 degrees minus 130 degrees. So if I should subtract that properly, I should get 112 degrees as my angle inside the triangle, which is A. Okay, now a part of the angle now has A. Looking at it very well, I have two angles, two sides, and one angle. That angle is, of course, an included angle. And in our previous classes, we learned that in solving triangles, one of the major conditions that we use for using cosine rule is that you have two given sides and an included angle. And this condition is what we have right here. So we have 112 degrees as the included angle, then 60 kilometers and 80 kilometers as the side. Then we can go ahead to solve our question. Let's go ahead. We imply the cosine rule. Using my cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. If I put the values of a and b respectively as 60 and 80, and my cos a, which is cos 112, if I put them properly, I should have my a, my side A, as 116.6 kilometers. So I'll do well to write that there. So the first part of the question, once again, is catered for. The distance between point C and point B is 116.6 kilometers. Moving forward, how do we get the bearing of C from B? The bearing of C from B. Now, notice our idea of from once again. Since we are saying from B, I will go ahead to draw my cardinal point at point B, north, east, south, and west, and I will attempt to draw my angle in the clockwise direction. Please always note bearings are always taken from the north in the clockwise direction to meet the line of reference. In this case, my line of reference is the line going towards C, and that is the angle I'm looking for. If I can get that angle, I'll get the bearing of C from B. But how do I get this angle? Let's take a look at alternate angles once again. From here, I realize that this is 130 and this also has to be 130. Why? We're talking about alternate angles. So if this is 130 and this is 180, everything here should give me 130 plus 180. If I can get this entire angle, then I can later on decide to find this angle. I subtract that from the entire angle, I should have my bearing of C from B. So let's do the first thing first. 180 plus 130 here should give me 310 degrees. So the entire angle we're talking about from B running clockwise to meet the line in A, coming from A, is 310 degrees. But how do I get the angle B? So we can just subtract it to get my bearing. I'll go ahead to use my sine rule. Now that I have three sides given and an angle, I can go ahead to use my sine rule. My sine rule here will simply say A sine B equals B sine A. And if I substitute my values of B and A properly, I should have sine B equals 80 sine 112 degrees divided by 116.6. My sine B will ultimately give me 0.6361. And if my sine B is that, it simply means the value of B will have to be the sine inverse of 0.6361. If you compute that properly, you should have B equals 39.5 degrees. So my angle B is 39.5 degrees. I'm not really looking for B. What I'm looking for is the bearing of C from B. So I'll go ahead to subtract. Mind you, what we just got is this angle B. And we said we're going to subtract that from the total, which is 310. To subtract all that, we get our bearing. So we can now say 310 minus 39.5 degrees should give us 270 degrees. Yes, that's exactly what we are looking for. Then I can go ahead to write my angle as 270 degrees. It is already in 3 digits. So the bearing of C from my point B now is 270.5 degrees. So we have successfully solved this question by looking for the distance between C and B and also looking for the bearing of C from B. Now, this is how easy it is to solve questions in bearing and distance. First of all, you must learn how to draw your triangle properly. Then secondly, learn how to apply the trigonometric ratios, the Pythagoras theorem, and of course, your sine and your cosine rule. So a quick recap of what we've done so far today. Yes, we just talked about the bearing. Now the bearing is always drawn. The true bearing are always measured from the north and taken in the clockwise direction. We also said the triangles can be formed from a given word problem to find unknown sides and unknown angles. especially in bearing and distance. And lastly, we just said that we can use the Pythagoras rule, the trigonometric ratio, or the sine and cosine rule to solve problems in bearing and distance. Okay, perhaps that will be all we'll be talking about today. But before I leave, I will always leave you with a question. So, let me have this. Classwork. Two men, P and Q, set off from a base camp R prospecting for oil. Now, P moves 20 kilometers on a bearing of 205 degrees, and Q, on the other hand, had to move 15 kilometers on a bearing of 060 degrees. Now, calculate the distance of Q from P. And the second part says, calculate the bearing of Q from P. Please quickly know that you have to give your answer correct to the nearest whole number. Now, this is just for you to be able to avoid, unnecessary approximation. And I want all answers to be the same thing. Now, the answer to this question should be on the note part of your page in your school portal. Just drop the answers there. Number A, question A should be so, and it has to be in kilometers. And question B should be in angles. The last class, I had lots of entries and lots of feedbacks from the work, the last class we did. Very impressive. And I believe this will be even more impressive than the last one. So take down the question. I believe in an subsequently we can attempt to solve this question together, but do well to drop the answers there. Also go ahead to the school portal. The very next page to this in the school portal will be the quiz, the second quiz for bearing and distance. About 5 questions, and these questions are WAEC standardized questions. Solve them within 20 minutes and get your result always instantly. That will be all for now. Please, till we get to have another class again, do well to solve lots and lots of questions in bearing and distance. Until then, be a good student and stay safe. Thank you very much.